This is a picture I had a student send me, and somebody in some remote village got a little too ambitious, okay? This poor donkey was trying to carry a little bit too much here. If you think about it, okay, this wheel right here is acting like a pivot point, okay? So in terms of the physics of what's going on, you just have too much torque in the clockwise direction compared to the mass of the donkey here. The minorly school inappropriate caption for this, actually it's okay, is this is what happens when your ass is too small. Okay, there we go. Trouble, okay? Anyhow, there we go. I know, some of you guys are still sleeping. There we go. Torque, what's a torque? Real simple. A torque is a turning or twisting force there. You apply a torque every time you turn a wrench, you put in a screw, you open a door, etc. Okay? If you think about it, it only really depends on two things. Okay? The symbol we use for torque is the Greek letter tau. Okay? It's a lowercase t there. Power to the Greek people, because we run out of letters there. Okay? Then the only thing that affects the amount of torque you can exert is a force that you apply, and then the distance from the pivot point. Okay? But the key is it has to be the force that's perpendicular to your point of pivot there. So if you think about, like, if you're pushing open a door or you're turning a wrench, it doesn't make sense to push along the pivot point, but perpendicular there. And intuitively, you kind of do that anyway there. So, like, how about if you're using a screwdriver? There we go, common sense, right? Can you turn in a screw with your bare hands? Kind of, not very well, right? So what does a screwdriver do? It increases your amount of torque there. How does it do that? Your force that you can twist with isn't necessarily increased, but what happens is, because you can have a larger distance from the pivot point, then you get more torque there, okay? How about this? It's a classic circus question, right? Can a midget clown pick up an elephant? And the answer is, yeah, of course it can, okay? And here's what it looks like. This is my little demonstration here. I'm going to show you guys this with my, oh, actually, I can't project that for now. That's okay. So here, I have a 1 kilogram mass, and I have a 1 kilogram mass and a 100 gram mass. This thing is 10 times heavier than this, okay? But, just like when your car breaks down, can you pick up a car and change a flat tire? You can. Now with your bare hands, you got to use what's called a what? A jack, a lever here, okay? So notice that 100 gram mass is picking up that 1,000 gram mass, the kilogram mass there. Even though that this thing is 10 times heavier, how come that little guy can pick up this big guy? Because it's got 10 times the distance if I want it to balance out. It's actually a little bit further. That's why it's lifting that. You see that? Okay? So the classic circus trick is, you take a big old elephant or whatever, or you have a clown here, and then you have a clown on the other end jump and then launch the other clown into a bucket of whipped cream or whatever. Okay? So in real life, we use torques all the time to multiply our forces or just to twist things and turn things there. Okay? You think about opening a door, same idea, right? Where do you want to push the door to open it? Do you want to push it right by the hinge? Does that work? If you push the door? Yay. Let's open a door really quick. Very exciting, right? Think about it. Where's the best place to push to open the door? If you want to leave class quickly, do you want to push right here by the hinge? Not very easy to do, right? So where do you always push? You don't push by the hinge. You look weird, right? You always push where? On the opposite edge, because then you maximize the torque, right? If you push 10 times further away from the pivot point, you multiply your torque 10 times. It's 10 times easier to open, right? If you push right on the pivot point, it's not going to work too well. Make sense? Okay? Also, if you think about the door handle, it's also about maximizing your torque. This kind of handle is easier for people to open. It's handicapped accessible versus a knob, right? Because you can exert a greater torque. So if you have arthritis or whatever, you want this kind of handle to open versus a normal knob there. If you push, you don't want to push right on the pivot point. That doesn't make sense. You want to push perpendicular to the pivot point, right? To maximize your torque. Okay? So it's kind of common sense. We just take it for granted there. Okay? So if you see me opening the door weird, it's because I'm trying to make a point there, right? That you don't want to make your life difficult, right, by pushing right at the hinge there. You want to maximize your torque by pushing away from the hinge. Got it? There we go. So for rotating doors, we do the same idea, okay? We avoid the crazy torque problems there. So in the end, if you know the force perpendicular and the distance, then you can calculate the torque.